design a computer network is a very, suppose you want to have a network in your organization. What are the things you have to consider? What are the things to be considered and how to implement a network there, right? Right. Okay, I hand over to Mr. Sudarshan to start his presentation.
Okay, so hope everybody can basically see my screen.
Yes, sir, it's visible.
Okay. So once again, good morning. So as I mentioned in my introduction, so I'll be talking about the practical aspects of Wi-Fi network implementations. So I'm not going to talk about any theoretical things like IEEE standards or any thing like that, but I'll be relating these conceptual things when and they are required. So I have introduced myself. I think it's no need to basically do this again. So we'll straight off move to our content. So when we are deploying a Wi-Fi network or any network, so first of all we should think why we need a Wi-Fi network. Okay, because there are different technologies, what you call last yard technologies that we can adopt, like wired things, Wi-Fi or any other things. But basically, why we need Wi-Fi networks and how to plan a Wi-Fi network. Okay, so first thing is the first question is a simple thing, of course. Why we need a Wi-Fi network? It is to achieve what you call mobile connectivity in an enclosed environment, enclosed what you call private net environment. Okay, of course you can use 4G mobile connection, 3G, 4G what you call mobile data network in order to achieve connectivity. Apart from that, these Wi-Fi networks are considered to be personal networks. It is in a confined area, in a defined geographical area, which is defined to be, it is called private. Okay, it is the main factor that we consider when we are selecting Wi-Fi as the access technology. So then we'll talk about how we can plan. What are the steps, the technical and the procedural way of planning and implementing what you call this Wi-Fi network. So 90% of my presentation slide will basically talk about that aspect. So when you are planning and when you are deploying a Wi-Fi network, there are three major steps that we need to follow. Okay, so as you can see in the screen, we need to do what you call a coverage and capacity planning activity. Then we need to do a predictive what you call site survey, and then we need to do a what you call a manual site survey. So first two things are basically, it is a proactive thing. It is under the planning stage, and the last line, the what you call this manual site survey, is doing after you basically deploy your Wi-Fi network there. So I'll be discussing in detail how we do this coverage and capacity planning, what are the aspects that we need to consider, and how we are performing a predictive site survey in our corporate environments, and how we are performing this what you call manual site surveys. Okay, so these are under the planning and what you call deployment part of Wi-Fi networks. So first, most important thing is that before implementing this your Wi-Fi network, you should conduct the coverage and the capacity planning activity. Okay, so as you can see in this picture, there are, I think, basically 5 areas, 5 factors you need to consider. First thing is that how many clients will be online. Online means simultaneously. Okay, if we are implementing this Wi-Fi in a small office room, it may be, say, maybe 10, maybe 4, 5, likewise. People who are planning to access, who require to access this Wi-Fi network, what we call simultaneously. And next, what are the applications that basically they will be using? Okay, so social media or any clients actually. Okay, it's about the so are they mobile users, mobile phone users, any
So considering the type of clients, I think different related to the Wi-Fi standard, no?
Yes, yes. Type Wi-Fi standard is basically related to them, as you can see.
Because some devices are supporting some standards, some are not. No, therefore you
Not
have to consider. For instance, some are working only 2.4 gigahertz only, some are working both 2.5, some are 5 gigahertz only, maybe like that. No?
Like that, of course. And you can see in this picture, you can see the Apple icon. It says 11N. Okay, and this Windows, this browser thing is 11N, and this is called Android ABG. So it is that IEEE standards, different versions, what you call. Okay, depending on the client, the what you call end device that is accessing the Wi-Fi network, the standards may differ. Standards are changing, so you need to basically focus on that. So as an example, if you are using this, if you are implementing what you call Wi-Fi network in a station, or say any type of enclosed public area, most of the users will be what you call a smartphone use. Okay, they want to access the internet to social media or some, but basically the end device is a smartphone. If you are talking about an office, most of the time that end device will be a laptop or an iPad or something like that. If you are talking about a warehouse, the wireless network using device will be a barcode scanner. Barcode scanner means what you call, so it is a wireless barcode scanner that is used to scan these barcodes of all the material that is being taken out and basically taken into that warehouse. So those devices use different standards. This is why it is important to have an idea about what is the end device is to be. Okay, and then the applications of those end devices. So as you can see, is it internet? Is it to send emails, social media, media streaming, video streaming, something like that. So it is where the bandwidth needs to be basically considered. Okay, if you have a, say, an advertising agency or a very sophisticated what you call graphical services like the photo, what you call video editing, some kind of a company, small company, they may use high bandwidth. They may need to use, because HD 4K videos they need to upload, download, something like that. It is about the bandwidth. Okay. Then the fourth aspect is that basically about how mobile, how frequent they move around. If I take my early example, if we take a station, railway station or something like that, people are basically highly mobile. They move around. They won't stay there for a long period. They basically move around. If we talk about what you call a shopping mall, people don't stay in one place. They basically move around. So it is about the end users mobility. So you need to have an idea about this end users mobility to place your access point, how the handing over you need to handle those things, handing over, taking over those things. It is a aspect that you need to basically consider. And lastly, how fast of course the throughput be. It is related to this the application that is being used. I explained to you the video streamers, content, what you call email senders, texting, social media users, different different network throughputs are expected. So if you don't basically analyze each and everything of this key aspect, your performance, your end users experience in your deployed Wi-Fi network will be very low. Okay, some may complain that they cannot connect to the Wi-Fi network. Some may complain that when they move from one location to the other, they are getting disconnected. Some say your network is very slow. Okay, some will say that our devices are not being basically connected through the network. So it is why we need to basically analyze these 5 areas basically before implementing, or what you call when you are planning the inceptions planning stage of this Wi-Fi network design. So next I will be talking about some bandwidth requirements per application. This is just to basically give you an indication. These are not actual 100% accurate figures. You can have an idea about how different applications requires bandwidth, how different applications bandwidth requires. Chatting, messaging, 200 kilobits per second, email, same, social media, 500, VoIP calls like we are doing at the moment. It's about 300 kilobits, video calls, 1.5, web browsing, file sharing, video streaming, likewise. So have an idea about this type of network bandwidth requirements based on the applications that the end users are going to use in your network. Okay. So next I come to
okay, before that, if you had a question, you can ask from Mr. Sudarshan. Or you can put it to the chat. Okay, Sudarshan, you can go ahead.
Yeah. Next I will be talking about performing this predictive what we call site survey. So basically why we are doing this, we cannot just basically go into a place, just observe the area in your eye and place access points as in places as we want. So if you do that, you will lose many things. Okay, you won't get the expected outcome. So I'll be sharing with you some screenshots and things. Why did I say that? Okay, so it is why in advance when we are planning a Wi-Fi network, we need to do this predictive site survey. So as the name implies, it is a predictive site survey. So to do this survey, we are using certain tools. Okay, there are tools available. Especially these tools basically come up with this enterprise Wi-Fi network service providers. If I mention some trade names, not to give them an advertisement, Cisco, Ruckus, or any Wi-Fi this equipment manufacturer, they have their own what you call proprietary predictive site surveying tools. Okay, you need to pay them or you need to have license for them to use. And on the other hand, there are some free tools that you can download in the internet and do this predictive site survey in a very limited but very which will give you some useful and interesting information. So what we do is basically in this application, it is a desktop or you can download it to your desktop or a laptop, and you can there are 2 ways. You can draw the flow plan. If you are planning to implement a Wi-Fi network in a particular office environment, you can draw the respective this what you call this flow plan in this software. Okay, you can mention where are the walls are, the thickness of the walls, height of the walls, the window positions, and cupboards, those type of things. And the other thing is that there are some tools, most of the tools, they facilitate uploading these building plans. If you are having a very comprehensive AutoCAD drawing in the of the flow, you can simply upload that flow plan into this software. So after that, it will analyze, and you have to mention, you have to configure in the application itself. I'll be basically showing you. So in a scanned flow plan or uploaded flow plan is just a simple diagram. Okay, the system don't know which of these lines are walls, which of these lines are windows. Okay, which are made of hardboard, which are made of brick walls. Likewise, system don't have basically any idea about that. You have to configure that. Okay, I'll show you. So these are some commercially using tools that we use in our industry. Okay, Zone Planner, Cisco, Air Magnet, NetSpot, and Thermography Site Survey are actually they are called free tools, and these applications can basically be used in this predictive site survey. So as you can see in my screen now, this is a very simple tool that can be downloaded from the internet free of charge, and this is how how you do a what you call this predictive site survey. So this diagram itself called a network what you call Wi-Fi heat map. Okay, heat map means heat mapping. Heat map means it shows the signal strength of the what you call this Wi-Fi signal strength in different areas of your flow plan based on the what you call positioning of your Wi-Fi access points. So in this diagram, I think it is not a what you call uploaded. Sorry, it is not an uploaded diagram. It is a drawn diagram. You can draw lines. You can see in these tools. You can draw lines, and you can mention, as you can see in this toolbar. Okay, it is a brick wall of 9 centimeters, metal filing cabinets, likewise. So you have to basically simulate the exact physical arrangement of that flow. If you draw the flows, you have to mention it is a brick wall. What is the thickness? Where are the cupboards? Where the metal cupboards are basically positioned? Where are the windows? Where are the mirrors are basically positioned? It is the actual what you call the live actual simulation of the exact physical area. So after doing that, the tool itself, if you are using what you call a proprietary tool, the tool itself give you the feature of placing different type of what you call Wi-Fi access points. If you're using a Cisco tool, it will list out in your left line the different type of Cisco wireless access points that you can basically deploy. So you have to just drag and drop them, and internally you have means if you go to that access point, you can configure their signal strength, their channels to be used. Likewise, I'll be discussing them later. So after that, if you run this tool in this, if you run this tool using this button, it will show you this heat map. So heat map means it shows how your Wi-Fi signals will be. So as you can see here, this if we take this access point number 2, this area is getting high signal strength. This is a low one. If you can see, so as you can see here, in the stairway or in these corridor areas, we have very what you call weak signal strengths. So inside small rooms, reception areas, something like. So the whole idea of this is to get some understanding about the physical flow plan and how different Wi-Fi access points can be placed, and if you place them like that, how the signal strength be. Okay, it is very important. So I'll be discussing how to configure these access points in detail in my later slide. So this is the simple idea of conducting what you call this predictive cell. I think it's clear.
Okay, you can ask some questions while we are doing to make this interactive.
Yes, of course. No questions?
You can ask from them.
Yeah.
Yeah, actually, what about the use of repeaters?
Yeah,
Besides-
of course you can. Of course you can place them. It is so as what so it is what I said that depending on the application that we use, it will show all the possible options that you can utilize. Access points, repeaters, anything. Okay, you can just drag them and basically place them here in this diagram and see how the network will operate. Network will operate means how the basically how the signals will be there after you basically deploy this.
Yeah, when you are implementing the network, maybe repeater also required, but later you will discuss about what are the devices can be used, no?
Yes, yes.
Under that one, you will study about the repeaters also and how these can be used.
Sir, do we have to define the electrical wiring as well? Like, like there
No.
may be some interference. So,
That's a good question. That's a very good question. I'll be discussing that later. But these diagrams generally they don't give facility to that. They just talk about this wireless interferences from access points and this what you call non-electronic devices. How the walls and this architectural components will basically affect your wireless network experience. There may be some tools, but I have not have not experienced anything like that. What you say? It's a good question. Yeah.
So what are the specific SLT repeaters, Wi-Fi routers mean?
I'm not going to talk about SLT things here. This is a concept that I'm talking about. How we are going to plan a Wi-Fi network. I'm not going to do any marketing activity for my company. Sorry.
Okay, you can go ahead.
Yeah. Okay, so it is. I think everyone is clear about this. Next, this is just to give you an idea about how different building materials affects network attenuation, Wi-Fi network attenuation. This is just to give you an idea. You can see synthetic asbestos, wooden doors, glass windows. Okay, heavy colored glasses, likewise, brick walls. This is just to have an idea. So you can see how it affects the 2.4 band and what you call this 5 gigahertz band also. Attenuation is almost say some areas it is near double. Okay, because high frequency signals do not penetrate. Okay, this is just to give an idea, and in relation to this diagram, how each material in your diagram will affect the transmission or the traveling of your Wi-Fi signals. Then after
Okay. Now can you go to previous slide? Now you can see the attenuation of the 5 gigahertz signals are high. Now Advantage of the 5 gigahertz band is it has higher bandwidth you can use, and the higher bandwidth channels, number of non-overlapping channel, everything is there. But problem is when the frequency is increasing, it is not going through a high distance, longer distance, because its attenuation is high. So you can see that when it is going to say asbestos wall, it's 4 dB, and the brick wall 2.4 gigahertz is 10 dB, whereas the 5 gigahertz is 2 times of actually 20 dB means not 2 times, 3 times actually, right?
Yeah.
Yeah, dB 2 times in the dB 2 dB means 3 times.
3 times.
Yeah, sorry, yeah, 10 dB higher. 10 dB higher means it's 10 times, right? So dB 10 means 10, dB 20 means 100 actually. So yeah, that also you have to see. That's why we cannot go to very high and higher bands in this frequency spectrum because of this problem. Okay, go ahead, please.
Yeah. So once we do our plan, once we execute this planning activity, then we generally what we do is we generally basically go to the exact location, physical location, and we place our these access points, these Wi-Fi routers, you may guess, repeaters, access points, and everything as we plan. Okay, and when we power up the system, we need to do what you call the manual site survey. Manual site survey is a very simple thing that we can do. You can use this manual, what you call this equipment manufacturer's site surveying tools itself, or in simple terms, you can use some applications, apps in your smartphone or a laptop. Okay, there are enough apps in the internet, in your app market. You can download to your smartphone, and you can and basically you can monitor the signal strength, the SSIDs, how in what channels they are operating what channel they are operating in a particular physical location. Okay, so it is to make sure that everything is happening as we plan. So as you can see here, there are some very strong signal areas which we need to basically cover. Yeah, but and at the same time, we cannot place any access point at that area because of some security reasons, physical security reasons. Okay, so if you place like this, if you go to this corridor area or some other room, we need to go with this this scanning tool or this application, and then see how actual what you call signal strength is there, and in what channel they are operating, and basically what other signals that we receive in that particular area. Because you may be receiving some other Wi-Fi signals from other access points which are not under your control. In the adjacent building or the next office, in your office area or something like that, it is also affecting your basic Wi-Fi network. So it is why we are doing a basic, what you call this manual site survey, to see how it actually exists. So this is actually a commercial figure that I'm showing. It is that it is an equipment. It is a simulation of an actual equipment that we basically use in assessing our Wi-Fi signal strength in certain areas. It is how it basically display in your screen. So you can see some yellow and gray color lines. Those are actually what is known as SSIDs, Wi-Fi signals that you basically received under each channel. And the blue colored ones are known as noise. So I'll be talking about noise because it is a very important aspect that you need to basically consider. How noise occurs and basically what contributes. Okay. So this is actually Wi-Fi Home, a very simple tool that you can download to your laptop. And if you run, you can see what are the SSIDs available in that particular area, their signal strengths, their channels that they are operating, and the 802.11 standard, whether it is BGN or something like that. The what we call this security aspects, vendor, and those type of things. So these are very important things that you need to consider when deploying your Wi-Fi network, because I'll be talking about those things later. This is a very dangerous thing, because if you can see your vendor, say that in this low 6 Wi-Fi, it is vendor is FIDA International S Private Limited. So any hacker or someone who's carrying this network knows who is the manufacturer of that access point. So these hackers generally know what are the vulnerabilities, okay? What are the vulnerabilities or weak points in that manufacturer's firmware or that operating software of that access point, and they can easily basically hack in. So it is something important that we need to basically consider. So I'll be talking about those things later. So it is how you can see in a real-time application. Same diagram in a more graphical way. So you can see this is our Office 1. It operates under channel 30 with the highest strength. So other ones, you can see how they basically overlap. Actually, in this scenario, I manually configured this to operate under this channel 30, because if I operate it under channel 7 or 6 in this area, there'll be a lot of interferences. So I manually configure this to operate in basically channel 30, and you can see here there are very less interferences in that band. So I'll be talking about those things later in my presentation. Okay, so it is about manual site service. So we now talk about how we are going to plan, what are the aspects that we need to consider, how we are going to do this, how we are doing this predictive site survey using the applications available and the attenuations, what contributes to them. And after implementing these access points in the practical environment, we need to go and do a manual site survey, and how this signal what you receive will be interpreted in your screen. Okay, so it is to have an understanding about how the network deployed will be basically operated.
Okay. You can allow them to ask any question they have.
Yes, so this is an important chapter that I am now finishing. So if you have any questions related to that, you may ask.
Yeah, rather than put into chat, better to ask to make it interactive.
Yes, make it interactive.
Sir, the manual site survey is being done like once after everything is set up. So in that case, like let's say for an example, an access point is mounted on the roof.
Yeah.
So in that case, like after that survey, are we going to like change, like based on the results that we get, are we going to change the locations of those devices, or just?
Yes, of course. That's a good question, because as I told you, in this diagram we are using to plan, we don't consider any external interference. Okay, only the building arrangement, their walls, the furniture arrangements, and something like that. But if you go to this manual site survey, you can see there are many other signals also. You can see here, no? If you are focusing on this BCP2, this thing, there are some other signals also. If they are basically, say as an example, if you have implemented this access point number 2 there, and their access point number 2 is operating in say channel for channel 7 or something, of course you can change their channel by the controller or the manually into another area, but if some noise is adding, okay, some noise adding component will be there. Of course, you need to basically basically
Yeah,
change.
that will be discussed later, no? The noise
That will be
adding
discussed later. But to minimize that, what you call relocations, we are using this site cell. The idea is that if you place your access points in this manner, your coverage will be in an acceptable level. That is the whole idea.
Thank you.
So, is there any restricted channel ranges in Sri Lanka in within these 2.4 gigahertz and 5 gigahertz channels?
2.4, no, there's no restrictions in Wi-Fi network. This is allocated by TRC. There are no restriction in it. This entire bandwidth can be used. You don't need license to operate.
Yeah, but channel 14 we can't use, no?
Channel 14, channel 14 we are not using.
Yeah.
Only from channel 1 to this segment only use. You can see this is highlighted in red also. Internationally, we are not using it.
As we learn in some countries like USA, some bands are restricted. Likewise, is there any limitation in Sri Lanka as well?
Normally,
No.
we are using the European standards.
European standards.
Okay.
So you don't need license to operate in this band.
What she asked is in some countries, some channels are
Yes.
restricted. Like the European, Japan, like that, USA.
Okay.
Normally, we follow the European standards.
European standard. Yeah. Okay, any more questions?
Another question. Yeah. When we talk about attenuation,
Yeah.
is there any effect from the water? If there is any water source somewhere, will there be any attenuation from that?
What do you mean by water?
Water source, some water, let's say there is a water tank somewhere.
Water tank.
Yeah.
So how a water tank, because Wi-Fi we are talking about and basically enclosed area. Okay, enclosed private area. Of course, if you are catering the requirement in an open area like a hotel near the swimming pool area, something, if there's a water tank, there may be an attenuation. Yes, of course.
Yeah, but it is not listed here.
No,
Yes.
this is just an
No,
internally signed.
water, it is not going through water, no, it is reflecting from there. In the Wi-Fi signals, we are not only receiving direct signals, it will reflect from several places and coming to you. So we collect all these things and we get the resultant signal normally.
Yeah.
So therefore, when it is going to the water tank, it may be not properly reflected. It may go through that one, and therefore energy may be less. But the sometimes reflected signal also a problem, depending on your location. So when you take the resultant signal, it can be destructive interference, something like that. So therefore, this Wi-Fi very difficult to predict as it is 100%. So sometime the daytime the Wi-Fi is properly working, nighttime it's not properly, or other way around. So that's why you are doing the predictive side save, and after that, Sudarshan say he'll explain how we go to the actually fixing these things. Okay. Is that correct, Sudarshan?
Yes, correct.
Yeah. Okay. Right. Go ahead, please.
Okay. So we'll basically move ahead. So next I'll be talking about the interferences. It is a very important thing because as Mr. Tilak said, you cannot predict. Okay, because Wi-Fi signals they vary due to many reasons. So next we'll talk about the factors what causes interferences and how to overcome them. So two sources can be technically identified theoretically. Those are known as non-Wi-Fi sources and Wi-Fi sources itself. Okay, so the interferences from these areas, what you call non-Wi-Fi, if you call it Wi-Fi sources, you can see in this diagram the prevalence and the severity of these things. You can see our Bluetooth, basically how it's affects. And the cordless phones, baby monitors, microwave ovens, jammers. Of course, the objective of jammers is to jam the network. And security digital cameras, how these things affect. Actually, I'll show you how these microwave ovens and basically Bluetooth basically affects our
So there is all these things are normally working in 2.4 gigahertz. Right?
no normally works in 2.4 gigahertz. Yeah. So this is the what you call Wi-Fi interferences caused due to a microwave oven. So as you can see here, this in channel 14 area, channel say 12 or 13, this frequency, channel 1, and some basically harmonics are there. These blue color things are known as the interferences or noise added by this what you call this this microwave ovens. This is a practical scenario, and it affects because we are getting many complaints that when we are, especially from the apartments, if we consider apartments, there are apartments are very enclosed, very closed areas. They use a lot of these devices, and at some point they say our signals are getting very low. We cannot operate our Wi-Fi network when we are.
Yeah, you remember when we did our fiber project, pilot project in the Crescat.
Yes.
There were so many complaints came like that. You know, after we installed the Wi-Fi router.
Yes.
Because these people are using many wireless devices, interference devices.
So we actually went there and basically measured them, and we found that there are a lot of interferences. So, but they complain is that even Wi-Fi, this Wi-Fi network is not working. Your fiber is not working well. We are not getting anything enough speed. It is delayed, something like that. But the actual cause is something different. Cause is actually their equipment itself, microwave ovens.
Because in the apartment, maybe the adjacent apartment, device,
yeah,
it is affected.
Yes, it is what happened there. I was about to tell that. So the neighbor's equipment, of course, it affects your network. So this is just to give an idea how a microwave oven interferes with your Wi-Fi network. This is about Bluetooth. Everybody uses Bluetooth today. You know, the earbuds, Bluetooth speakers, Bluetooth operated, many things are there. So this is how it operates. You can see it basically how it affects in channel 1, 2, this 3, 8, 10, up to 9, and some what you call harmonics are also there. So it affects. So as you can see in this diagram, if any Wi-Fi signal, Wi-Fi channel is operating in channel 2 or channel say 9, channel 12 or something, these people will get a very bad experience in their Wi-Fi network because a lot of interferences are occurring from outside their network because of their Bluetooth itself. It may be your Bluetooth, this earbud or hands-free kit or something like your what you call Bluetooth speaker or something like that. It is unpredictable. Okay, so depending on the situation, this figure will basically vary. So this is to give you an idea how these microwave ovens and Bluetooth devices, which are known as non-Wi-Fi sources, basically affects your Wi-Fi network performance, interferences. Okay. So this is from non-Wi-Fi sources. Sorry, this is wood. These are material, plaster, synthetic, water. You asked something about that. Medium, bricks, marble, metal, and mirror. So the last thing that I basically highlighted is a very important aspect. It is about mirrors. Okay. So when we are implementing Wi-Fi solutions to the hotels, like apartments, like very architecturally, very aesthetically appearing, very nice buildings inside, the architects used to use a lot of mirrors. It is to make the room much bigger or some other reason. It is visually pleasing, but it is the worst enemy of this Wi-Fi network because these mirrors reflects. Okay, 90% of the almost 90% of your what you call this of your Wi-Fi signals. So if you place an access point in somewhere and if you have a mirror in some wall and you are going to access your Wi-Fi network behind that mirror, you won't get it. All the signals will be reflected through this mirror because Wi-Fi signals itself an electromagnetic wave as light. Okay, they use this mirror used to. It's supposed to basically reflect all the waves. So it's a very important thing that we need to keep in mind, and we get a lot of complaints there when we go there and when we see that they have placed certain mirrors, some metallic objects. These things will actually affect your what's called Wi-Fi induced experience. These are something that you need to basically keep in mind. And non-Wi-Fi, what you call non-Wi-Fi sources, other things are these hearing aids, blasting area. Someone asked about power lines. Of course, it is affecting, especially the high tension lines. Devices. Okay, this is just to give an idea. So keep in mind of these things. There are many factors that affects the signal experience, the induced experience of your Wi-Fi network. So then I talk about from Wi-Fi sources how the interference basically appears. I think you have learned all these things in your theories. First thing is called co-channel interference. Co-channel interference means every what you call every node, what you call every client or every node, if they are operating in same channel, they compete to talk in the same channel at the same time. So it is an interference cause. It is known as co-channel interference. So there are two diagrams. The first diagram at your left shows that every device operates in the same cell under one channel. The second second diagram at your right shows actually what you call two-way circles. There are two cells which operates under what you call same channel. So the middle device, this laptop at the center, it operates in the same channel, but two sources are basically two access points from two cells are transmitting signals. So it is again co-channel interference. Simple idea is that all devices that are communicating operates in the same channel, it will cause co-channel interference. So I'm not going to talk about these things very deeply because I think you have learned this under your theoretical things. And then it comes adjacent channel. Adjacent channel interference means if you take this Wi-Fi, this bandwidth, this what you call this channel lineup, there are some channels which are interfering, which are adjacent to basically each other. Channel 4, 5, and 6. So as I can show you here, if you can say this, there are 14 channels. Of course, 14 we are not going to use. If we take channel 1, 6 and 11, they are not overlapping. All other channels, they have some overlapping part with their neighboring channels. It is called it is what is known as adjacent what you call channel interference. Channel 4, channel 5, and channel 6, they have overlapping frequency components. So that will cause interference. Okay. This is how in that same tool, how we can basically how we can analyze. You can see that this channel 6, channel 7, channel 8, and channel 4 also, there are some overlapping parts here. So it will cause interferences, and any equipment that is at that moment operating in that frequency range, it will have very bad experience in accessing the network, slowness or some what you call delays, something like that.
Okay, you can allow them to ask questions. If they have.
Yes, yes.
Any questions you have?
Data center is using a water tank.
Yeah, water also have some interference. We showed that or no? Okay. Right. Any other questions from this area? It's question asked, does all Wi-Fi routers use same channels or different channel?
So I'll be explaining that later. You can configure that.
It will
OS
be explained.
automatically,
Okay.
it will be explained in detail in later.
Okay, go ahead, please.
So next, basically how to overcome this problem. A good channel reuse plan can be adopted, and of course you can use predictive this planning software which I have basically shown you earlier. What you mean by a good channel reuse plan is that if you take the 2.4G band, there are, I showed you, here there are channel 1, 6, and 11 which are not basically overlapping. So you can assign your access points, any access point that are which are having signals that are overlapping with each other in your coverage areas. All the adjacent access point you can assign with this what you call non-overlapping what you call channel numbers 1, 6, and 11.
Now, how is the channels selected
Yes.
for particular device? We can explain that. You first.
Yeah. Channels are basically channel. What you call is that there are actually two ways. First thing is that of course it is automatic. If it is set to automatic mode, then the access point or the device itself will basically monitor. It will measure the what you call interferences and other factors that I already explained, and it will automatically change its channel. Okay, and it will be operating in an optimal channel. That's the number one method.
And automatically time to time channel also can be changed. If it is using one channel, suddenly if get interference, then automatically it will change to another better channel.
Of course, it is in the automatic mode. So in the manual mode, you can define this access point only to operate in channel 1, then channel 11, so it won't change. But the bad point is that if some external source comes in and interfere in that channel, the access point won't change because it's set to manual. So those are the things that you need to keep in mind when you are configuring your access point. It's important. I'll be talking those things in detail later. And how to overcome, I was basically talking a good channel use plan and to use predictive planning software. So I told you at that point, in these predictive softwares, we can configure the access points on their signal strength, their channel usage, and all the parameters. And you can see visually how it overlaps and basically how it interferes with other access points configured in the system itself. I told you about these things, non-overlapping channels. So this is the simple way of configuring your home router. Because I took this screenshot because it's a very simplest way to do this. So every access point, Wi-Fi access point, has this type of feature where you can see assign on which channel to operate. As you can see in this drop-down list.
Normally your service provider, you can ask from the service provider what is the IP address to be used to go to this site.
Yeah. Because it is generally it's a simple thing, 192.168.1.1. And if you type in your admin username and password, then you can go to the configuration page. Simple as that. And
Is
the and
192.168.0.1 or 1.1 normally?
0.1 for this FTP, what you call this fiber access points called what you call
Fiber connection.
these fiber connections. It is for this optical network terminals (ONTs). For ADSL routers, it is 1.1.
Yeah, at your home, you can type, if it is the copper one, 192.168.1.1, then you can go to the site and it has the username password. Normally username password both are admin. Then you can come to the screen. No?
Yes.
Yeah.
And the screen means it is the what you call the configuration page. There are some different tags. You need to go to this Wi-Fi interface tab, and under that you will find all these.
Is it possible to you to show it now online?
Uh, No, I don't think so because
Okay.
yeah. Yeah.
Security reason. Okay, right.
Yeah.
Any question you have from these students? Okay, then go ahead.
Yes, this is how you can assign different channels to your access point. It is manual, okay? So then there's another thing to be considered. It is known as the hidden node problem. I think you have learned this thing. Hidden node problem is that if we consider this example, there are 3 nodes, A, B, and C. If we take
these things you can go fast.
Yeah. So hidden node problem, I think you have learned, no?
Yes.
Yeah. So there's no need to explain. So how to overcome? Yes, you have to implement, you have to enable IP 802.11 RTS request to transmit, confirm to send RTS CTS in the router itself. It will overcome this issue. This protocol is this standard is being introduced to overcome that. And you can increase the power on all client stations, decrease the power on the hidden node station. On the access point power, you can increase, redesign another AP. There are different aspects you can read and understand how to issue this what you call hidden node problem. And other thing is that I want to mention that wireless interferences is the carbon monoxide of the wireless world, invisible, tasteless, odorless, arriving without warning, with the ability to really ruin your day, unless you know the symptoms and have the right tools at your disposal. It is all what I have explained now. Because
when you are using your wireless network, sometimes at your home somebody is using microwave. Then suddenly your signal may be dropped without your knowledge. So that kind of thing. So even if somebody with the airports or something, still it can be happen. No? So therefore it's very unpredictable and sometimes it is painful sometimes. No?
Yes.
Okay.
It is why it is important to have an understanding about these things because our people tend to basically complain to the operator that your Wi-Fi is not working, but the real cause itself is at your home or your office itself. You need to, if you know about these things, you can basically solve the issue. It's the whole idea. So next I'm trying to talk about this Wi-Fi controller. So we talk about this what we call channel allocations, the interferences, signal strength, and many aspects. So how we when we are implementing a Wi-Fi network in our organization or our some locations, how we need to configure this? What are the aspects? How can we basically deploy these access points with the control? So
now I can add to this one. That is if you have one router, there is no need to have any control. But if you are covering a large area, you need many access points.
Yes.
Then you need to control these routers, the access point, by considering what are the channels they are using. Is there a adjacent channel interference is there, co-channel interference there? Based on these things, you have to do some the controlling part. So for that one, you need a Wi-Fi control. This is similar to mobile network. The access point is similar to the base station in the mobile network. And in the mobile network, you have something called the base station controller. Those who know mobile network, then you can see the same scenario. You know the Sudarshan?
Yes, sir.
Yeah.
It is similar architecture. Isn't it?
Okay.
So the Wi-Fi controller's role, it automatically handles the configuration of these wireless access points, as Mr. Clark mentioned. If you are using multiple access points, you need an access controller in order to manage them. If you are using a one access point, you can manage it itself. No need to have these controls. So this what are the key functions? The interference detections and avoidance. So if it detects, it monitors the signals transmitted and received by and from each access point, and it monitors whether there are interference in certain channels, and they automatically adjust the RF, this radio frequency signal strength. They automatically change the access points operating channel to other possible channels to avoid or minimize the interferences. And load balancing is very important because if you have deployed 2 or more routers to basically cover a hall or a separate confined area, if their coverages overlap, then it detects whether a particular access point is being overloaded with clients and some other access point in the vicinity is underutilized, then it automatically handles what you call this load balancers. So the clients will be automatically transferred, is handed over to other basically other access point automatically. It is the core function of this this is what you call the wireless controllers, and it ensures, it's supposed to ensure that the entire area is being structurally covered by controlling the RF signal strength and everything. So I have mentioned some what you call proprietary or OEM Wi-Fi controllers. Cisco is a leader in this segment, and Ruckus also, Fortinet, some other feature. And the important thing is that I'll be talking in my next slide. These Wi-Fi controllers basically bundle this Wi-Fi controlling function with what you call security features. So Wi-Fi security.
Okay, you can allow them to ask any questions they have.
Yeah, sure.
Somebody asked, if we connect multiple access point to a router through a switch, does it will use same bandwidth of router or it's separated among a access point? Fatima, can you explain your question?
I have seen in some areas they connected all access point to a single switch, and for that switch they connected the router. How it works and how is there any when we implemented such a Wi-Fi network, does it impact on the bandwidth of each area, like the signal strength, like that?
I didn't get that question.
When we using a multiple access point, how those multiple access points are connected to a single area, that means single
No, question is
transmitter.
now, as the backbone normally connected to the switch to connect these all access points.
Yeah.
So in that case, she is asking if we connect multiple access point to a router through a switch, does it will use same bandwidth of router? It's separated among access point.
I'll be talking about that later. It's a good question. You can have both. You can utilize the same bandwidth, but depending on the nature of virtual what you call segmentation, you can have separate VLANs. So I'll be talking that later. It's a good question.
Yeah, and basically the what is the bandwidth coming from the router is to be shared by. It's the pipe coming to your
Yes,
home.
it is. Yes, yeah, it is obvious. No, it is
Yeah.
obvious. But you can assign QoS if you define separate VLANs for separate Wi-Fi access points and separate traffic types. You can assign separate SSIDs also and VLANs, and you can assign what we call is QoS policies, quality of service policies at the router level, so that VLAN will get priority. So there won't be any condition in there. That is possible.
So in that concept, in that setup, do we connect this Wi-Fi controller to the backbone or in separate wise?
Backbone means?
And that means this Wi-Fi controller will connect to that switch, or we use separate controller?
No. This is a switch is a different thing. This Wi-Fi controller is a basically server type of thing. Okay.
Yeah, it can be like this. Now, suppose we are putting a several access points in a flow. You can have one switch in the flow and connect all these access points to there. Another flow, another switch, and several access points to there. All switches also can be connected, but there will be only one Wi-Fi controller for all these things connected. I think there is a diagram also later in the lecture. No, Sudarsh, there's a diagram also, no?
Yes. I'll be explaining you this later.
Yeah.
These are deployment parts.
Okay. You will understand it later. Okay, go ahead, please.
Yes. So that's about Wi-Fi controllers. So then I want to talk about Wi-Fi security, a very important thing, because Wi-Fi signals travels everywhere. So as you can see in that what you call heat map, you cannot predict where your Wi-Fi access points signal is being transmitted to. Okay, so depending on the nature of the environment, the building, it will travel to destinations you don't even imagine. So I have seen in some cases, not in our country actually, when we are doing this under trainings under this security aspects, they have shown us there are stairways. Okay, the building's stairways acts as a duct to transmit their Wi-Fi signals from bottom floor to the other floors. So the Wi-Fi has reflected in the boundaries in these walls and transmitted to the top in their what you call stairways. Okay, so someone at the top can basically receive your Wi-Fi signal, and if he use some hacking tools and some other stuff, if he's very smart enough, he can basically get into your network if you have implement very weak security. So it is why security is very important in this domain, in this Wi-Fi. So some best practices, some basic things that I want to highlight. You can use encryption. Of course, it can be basically configured in your Wi-Fi router itself, if it's the case of the home router, and in the access point itself, if we are talking about your what you call corporate network, you can use encryption. Use mutual authentication. Only the authentication, these functions shall be implemented so that authenticated devices are only allowed to be connected to the network. Then the wireless network name and SSID plays a key role in wireless security, because you need to change the what you call default SSID. I told you earlier. Why? Because as I showed you earlier, if you use a manual site scanning, the Wi-Fi scanning tool, if you transmit your device SSID in a basic default way, you know that this ProLink router or something like that, then notice something else. It will be basically one route. So as an example, if you are deploying a Wi-Fi access point to your CEO's office or the boardroom, and you put some high bandwidth allocation to that, and because what happens is that these top management people, they generally basically don't like to use this password and stuff. So what people do is that it is not a good practice. I have seen that somehow keeping these access points basically open so that they can connect to their network straight away. Okay, free type of thing. But the SSID says boardroom Wi-Fi, CEO Wi-Fi or something like that. And that SSID, that signal transmits over to the other building nodes. So they will also detect the same signal with the same SSID. If it is open, then they can get in. And if it is not open also, if it basically shows that this is fine as CFO's or CFO's Wi-Fi or CEO's Wi-Fi, boardroom Wi-Fi, something like, people will try to get into that network using that SSID. You should not disclose any nature of application with your SSID. And you can disable SSID broadcasting. So if you do that, your SSID won't be visible to anyone. You have to manually type in your device to connect to the particular network. I think you know these things. And of course, you can increase the beacon interval. Beacon interval means just a frequency in how many milliseconds that the SSID is being transmitted. Okay, so if you increase that interval, it will be transmitted that in a less frequent way. It will add much security than usual. Then you can implement MAC address filtering in the router level or the access point controller level. You can configure what MAC addresses are allowed to, what endpoint MAC addresses are only allowed to basically connect to this Wi-Fi network. So recently I went to India for some training matter in a university. They collected our laptops, MAC addresses, everything, and they manually configured. So I was thinking how they are doing this. Because they have about 20-25 participants, but all of them they did in a very nice way. But and that is their practice. They use MAC address filtering. So it is the most secure one because only the MAC address, only the defined MAC addresses are allowed to basically connect, and MAC addresses are basically unique. There are no two MAC addresses in the same type. So it is a level of security that you can basically address. So actually we did in our organization when we're implementing our Wi-Fi network in our warehouses. Warehouses uses these barcode scanners, wireless barcode scanners. But near to our warehouse, there are some other organizations also. We need to basically set the signal strength to a basically high level because we need to use the Wi-Fi network all over inside the warehouse. And we only allow the MAC addresses of these barcode scanners in our router, in our access point. So only those are basically allowed to connect. So it is a level of security that we basically implement. And it is client IP address allocation. It's like disabling DHCP in the Wi-Fi network. and a manual Wi-Fi, these IP addresses can be allocated and assigned to each and every individual. So these concepts are not practical if your users are very dynamic. Okay, if the same person is basically sitting in the same area, in the same all over the time, these concepts can be applied. Otherwise, it is if they are dynamic, these are not practically possible. It will add an administrative overhead to you, which is not practically possible. Okay, and the other thing is that virtual LANs you can assign for data, voice, guest network, and what you call bring your own devices. And for the management network also, it is known as out of band management. We don't generally assign this Wi-Fi, this access point. If you have a controller and access points, their management part is performed in a separate VLAN, which is known as, if we termed as out of band management. The data load, that the normal payload traveling band is not being used for their management. We assign separate VLANs for that. And for the other part also, if you are using for data, separate VLAN, voice, different separate VLAN, same access point we can assign for guests to access with some added security and some limited usage options. And BYOD. BYOD is a very important thing that most of the organizations allow their employees to bring in their own device, their own laptop, their own iPad, their own phone, or some phone is not there. Basically, what you call tabs and laptops, they need to bring in. They can bring in their own and connect to the corporate network. So this BYOD VLAN is a separate thing with some added security. So it is before connecting to the corporate network, there are some security scans, some pre-defined security templates are there. It will automatically check your end device whether it complies with the defined security standard. And if it complies only, you are allowed to access the corporate network under this BYOD, what you call VLAN concept. Same to the guest network. If we take a lobby area in an organization, lobby area outside the CEO's office or the boardroom or the corporate office, some guests will be there to meet a CEO or to participate for a meeting. They can access your same Wi-Fi access point under what you call the different SSID assigned for the guest network. So under this guest network SSID, that VLAN, you cannot access your corporate information. Only the internet will be allowed with some restrictions, some bandwidth limitations or something like that. It is how you basically simply how you deploy that in your and configure that in your organization. It's about VLAN segmentation. So this is again some screenshot in your home router where you can configure these the parameters that I have already told you in my presentation. So you can show the beacon interval.
Can you just tell about the SSID?
Yeah.
SSID is the parameter to identify
the network
router. No?
Yes. It is to SSID is the parameter, the name that used to identify what you call this wireless network of course. So this is again not a good security practice, as you can see, although I mentioned SSID, it is mentioned as ZT. ZT is it is a router. So anyone
you can change the name, no?
You have to change the name because ZTE routers may have their own vulnerabilities. So this is, if you disclose this, what you call this hackers duty will be much easy.
Yeah, 50% is easy.
50% easy, as he knows what is the access point brand.
And they know what are the vulnerabilities flows in the router and how to attack.
Yes, of course. It is how you basically see. This is a very simple configuration page, but if you go to corporate routers, there are much more other parameters, and many are not manually configured. We set into auto mode where the access controller itself.
Okay, Sudarshan, how many more slides you have? The time
Only
is
two, only two slides.
Okay.
Yeah. So then Wi-Fi deployment, the best practices, it's about 15 to 20% overlap, 15 to 20 maximum users per AP, coverage for sensitive areas separated from other areas, enable QoS for video and voice. I have told you those things, so I'm not going to explain you. This is about the Wi-Fi deployment. I think someone asked the question, wireless channels, how this we can do. All the wireless tires can access the access points. Access points are connected to the flow switch. Flow switch means a switch assigned to a particular flow. That flow will be connected to a backbone switch or a router. Then they are connected to the gateway. At the gateway level, you can implement this automatic configuration server, also known as the Wi-Fi access point control. So the configuration service I mentioned earlier, it is bundled with additional security features like this gateway filtering, content filtering, and something like that. It depends on the license that you purchase. This is the simplest way I can explain how you can deploy this Wi-Fi equipment in your office corporate environment. This is another model because here earlier one, this controller is in basically on premise. It is in your premises. In this environment, this is a small branch offices. They are connected to the internet gateway, and the controller is basically what you call a cloud-based solution. This is also another deployment model where the controller stands in the cloud, where you have the subscription model or something like that. This is another possible deployment model. If you have, although if you have an on-premise one in a single building, also we can apply this. But in a branch divided network environment, this is also possible. So as you can see here in these red lines, I have shown you all the control networks. It is a separate VLAN that we basically configure.
You can have the cloud-based Wi-Fi control also. It's a managed control.
It's a managed control. Yes. So then again, this is about separating what you call traffic. I had told you about the guest network, corporate data, corporate voice, or something like that. It is how you manage, and you can assign different virtual LANs for data, voice, guest, and if you are using BYOD or something like that. Also, depending on your need, you can define separate VLANs for them and apply different security policies for them. It is the practical way of basically doing this. These are some equipment that you can utilize to basically deploy. So generally, we in a very like hotels or something, we generally do not like to implement power lines separately and data network separately. We use PoE switches. PoE means what you call power over Ethernet. Power over Ethernet adapters and PoE switches can be used to transmit data and what you call power in the same cable. So these equipment are much expensive than the other ones, but based on the ease of management and the aesthetic appearance related factors, we are using this PoE concept in order to basically deploy access points in open areas. These are some captures that are basically available in the internet. You can browse and basically find many other versions also. So that's all I have to tell you. If you have any more questions, you can ask.